Hello, everyone. Today, we're continuing our exploration of Flutter and starting with an important topic, working with references in Dart. We'll also go over built-in methods like toString, hashCode, and ==. In Dart, as in most modern programming languages, objects are managed through references. When you create an object, it is placed in a specific location in memory, and the variable you assign this object to actually stores a reference to the object in memory, not the object itself. Simply put, variables don't contain objects, they contain pointers to them. Let's try to create an instance of a simple class and assign it to a variable. As we already know, our variable holds a reference to this object, not the object directly. Now, let's create another variable and assign it the value of our first variable. Since these variables only store references, they both now point to the same object. Let's conduct a small experiment to confirm this. We'll change a field in our first variable and then print the values of both variables to the console. When we run the program, we'll notice that by changing the first variable, we also change the second one. The reason is that we modified the objects stored in memory. As a result, all variables that reference this object will also, so to speak, be changed. It's important to understand that working with references only applies to objects. In Dart, objects include all data types except for primitive types like int, double, bool, string, etc. Primitive types are passed by value, not by reference. Let's verify this. We'll create a variable of type int and assign it a value. Now, let's create a second variable and assign it the value of our first variable. If we change our first variable and print both variables to the console, we'll notice that they differ. This is because this time the variables store the value itself, not references to an object. Now that we understand how references work, let's move on to the built-in methods. Every object in Dart implicitly inherits from a base class called object. It inherits certain methods from this class, such as toString, hashCode, and ==. When creating an object, we can override these methods. Let's start with toString. This method returns a string representation of the object. By default, it outputs information about the object's type, but it can be overridden for more informative output. Let's do that. This is done through the usual overriding method we've covered before. Note that its return type is string. Let's have it return our field as a string. Let's test it now by calling it to print to the console. As we can see, our method works. Note that when it comes to the print method, we don't need to call the toString method separately since it is implicitly called in this case. Next up is the hashCode method. This method returns an integer used for creating hash tables and other data structures based on hashes. You probably won't fully understand what this is yet, but we'll cover this topic in more detail in the next lesson. If two objects are equal by value, determined using ==, they should have the same hashcodes. By default, hashcode is computed based on the object's location in memory, meaning by reference, which makes each object unique. Let's create two instances of a class with identical fields and print their hashcodes. When we run the program, we'll see that our hashcodes differ, even though the objects are essentially the same. This is because, by default, hashcodes are computed by reference, And since we created two different objects, their references are different. We can override our hashCode. In Dart, it is a getter. We covered them in the previous lesson. To override the getter, we'll use the familiar @override annotation and the following syntax. Notice that we made it so that it computes the hashCode based on our field. Since the field is of type string, it will be computed using a specific formula depending on the string. Note that our field also has a hashCode getter, as absolutely everything inherits from object and has built-in methods. This way, objects with the same name will have the same hashCode. Let's now check what gets printed to the console after overriding the method. As you can see, our hashcodes are now identical. Now, let's talk about the equal sign operator. We've already covered it. The logical operator equal sign is used to compare two objects. By default, it checks whether two variables point to the same object in memory. For example, if we have two objects with identical fields and print the result of our equality check to the console, we'll get false. Even though our objects are identical, we haven't overridden the equal sign operator, so it checks by reference. Let's try overriding our operator and compare it based on our field. This is done in a somewhat unusual way. Here's what the syntax looks like. First, the return type of the operator is bool, since we get either false or true as a result. Next, we use the keyword operator. It's used for overriding operators. After that, we specify which operator we want to override, in this case equal sign. Then we specify a parameter because when we compare something, we're comparing it to something else. In this case, it will be any other object. Let's return true, only if the other object is of type person and the name of the other object matches the name of the current object. As we remember from previous lessons, this is done using the keyword is. Using the logical and operator, we'll also check for name equality. Let's check the result of the equality test again after we've overridden the operator. As we can see, it now returns true. In this video, we've introduced you to built-in methods and references. In the next lesson, we'll cover collections and delve deeper into today's topic. Don't forget to subscribe to the channel and hit the like button if you enjoyed this video. See you in the next lesson.